Dear students, in the class we are going to discuss problem in functions of several variables. Already we have discussed what is mean by function of several variable when z equal to f of x comma y is a function where z is the dependent variable this x and y are the independent variable. So when the function is having more than one independent variable, it is called the function of several variables. At the time we can find that dz equal to dou z by dou x dx plus dou z by dou y dy. In case x and y are functions of t, then we can find dz by dt equal to dou z by dou x into dx by dt plus dou z by dou y into dy by dt. So based on this formula we will discuss few problems in the total differential. For example, first problem, find du by dt when u equal to sin x by y, where x equal to e power t, y equal to t square. We can write the solution for this. Can change this pen. Okay, here given u is a function of x and y. See, x is the function of t, y is also the function of t. U is that function of two variables, then we can find that dou u by dou x, dou u by dou y. But x and y are the function of only one variable, then we can find only ordinary derivative dx by dt, dy by dt. Therefore we can write that du by dt by the total differential formula, that is equal to dou u by dou x into dx by dt plus dou u by dou y into dy by dt. Here you should know when you have to use that the partial derivative and ordinary derivative. here you can see u is the sin x by y, x is the variable, y is the variable. At the time u is the function of two variables, therefore you have to use the partial derivative. X is that only one function, y is that only one function of t. At the time you have to use that ordinary derivative. So we can find that now one by one. What is dou u by dou x? Dou u by dou x means differentiate u partially with respect to x. At the time keep y as constant. Keep y is constant. So when you keep y is constant, what is sin x? Sin x actually it is like that function of function rule. It is the composite function. Okay, so here sin, differentiation of sin is cos of x by y. Then here once again you have to differentiate x by y. When you differentiate x by y, keep it 1 by y as constant. Differentiation of x is 1. Okay, so you will get that 1 by y cos of x by y. Next you have to find dou u by dou y. When you are differentiate with respect to y, you have to take it that x is a constant. X is a constant. So dou u by dou y equal to, once again sin is cos only, cos of x by y, cos of x by y, and then x is constant, na, keep it x. Differentiation of 1 by y is there. You have to differentiate 1 by y. So differentiation of 1 by y, we know that differentiation of dy of 1 by y is minus 1 by y square. So using this, the result here we will get that cos of x by y and then minus x by y square. So we will get that minus x by y square cos of x by y. See, sometimes what happened is the students are doing differentiation, find that dou u by dou x. In case the given function is that u equal to sin of x by y, then they are finding that dou u by dou x is cos of, that is they are differentiating with respect to x, means they are finding that they are writing like that. It is wrong. Okay, so you have to be differentiate carefully. So we can erase it now. So this type of mistakes you have to be avoid when you are doing that partial differentiation. So here given that x equal to e power t, so we have x equal to e power t and y equal to t square. Next we have to find the dx by dt. So differentiation of e power t is e power t only, dx by dt is e power t. dy by dt equal to, we know that t square is 2t. Substitute in the formula du by dt. So we know that du by dt equal to, once again I write the formula, dou u by dou x dx by dt plus dou u by dou y into dy by dt. Okay, So here few peoples may be having that more doubts in that partial differentiation. So these peoples have to go through the +1 +2 book once again. You will be get the clear cut idea on this. So dou E by dou x is 1 by y cos of x by y, and then dx by dt is e power t plus, and then you plus here, but here you get that minus x by y square cos of x by y into dy by dt is 2t. So here we can write that e power t by y is t square, na, substitute that cos of x is e power t by t square minus x is e power t, and then 2t is there here, so 2t e power t divided by y is t square, therefore y square is t power 4 cos of x is e power t by y is t square. So that is equal to e power t by taking common t cube cos of e power t by t square common. So e power t by t power 4 t square is there here, therefore t get cancel, can t cube, so therefore remaining is t here minus 2. This is the value of du by dt. It is the answer for this. Next example, if z equal to function of x comma y, where x equal to e power u cos v, y equal to e power u sin v, show that y dou z by dou u plus x dou z by dou v equal to e power dou u dou z by dou y. So given, write the solution here. solution. Given z equal to f of x comma y and x equal to e power u cos v, y equal to e power u sin v. dz equal to, so what is dou z by dou u? Dou z by dou u equal to dou z by dou x and dou x by dou u plus dou z by dou y dou y by dou u and dou z by dou v formula dou z by dou x by dou u dou v plus dou z by dou y into dou y by dou v. Since z is a function of x and y, x is the function of u and v, v is also the function of u and v. What is dou x by dou u? Dou x by dou u is e power u sin v. You are differentiate keeping v as constant. Similarly, dou x by dou v in the text keep it u as constant. So what is dou x by dou v? Minus e power u sin v. Similarly, we can find dou y by dou u. Dou y by dou u is e power u sin v. Dou y by dou v is, then dou y by, this one is e power u, it is cos, dou x by dou u is e power u cos v. Dou x by dou v is minus e power u sin v, yes. Dou y by dou is e power u sin v. Dou y by dou v is e power u cos v. Now we can calculate dou z by dou u. Therefore, what is dou z by dou u? Dou z by dou x, dou z by dou x into dou x by dou u. Dou x by dou u is e power u cos v plus dou z by dou y e power u sin v. So you can take that e power u outside. The remaining is dou z by dou x into cos v plus dou z by dou y into sin v. What is dou z by dou v? Dou z by dou v equal to, first dou z by dou x we can write then minus e power u sin v plus dou z by dou y e power u cos v. Therefore, in case if you are taking that e power u outside, then dou z by dou v becomes e power u taking outside minus dou z by dou x sin v plus dou z by dou y cos v, since you are taking that e power u outside. Next, you have to find that y dou z by dou u plus x dou z by dou v equal to y e power u dou z by dou x cos v plus dou z by dou y sin v. We are taking from here, that means you are different multiply with y of dou z by dou u. So dou z by dou u is there here, dou z by dou u is here. From this you have to multiply with y here. In case if you are multiple with y here, you will get this answer. Then plus x dou z by dou v. So dou z by dou v is here, you have to multiply with x here. So plus or minus here plus x e power u minus dou z by dou x sin v plus dou z by dou y cos v. So y is substituting y here. What is y here? Y is e power u sin v, x is e power u cos v. You have to multiple this. If you are multiple this, you will get that e power u into e power u, e power 2u, that is e power 2u sin v, then dou z by dou x cos v plus dou z by dou y sin v. Similarly here you have to multiply with x. X is e power u cos v. So e power 2u cos v minus dou z by dou x sin v plus dou z by dou y cos v. Therefore e power 2u I can write outside, then multiply inside that sin v and cos v, dou z by dou x sin v cos v plus dou z by dou y sin square v minus dou z by dou x sin v cos v plus dou z by dou y cos square v. So what happened here? So this term dou z by dou x sin v cos v and dou z by dou x sin v cos v get cancelled. Remaining things are there. So these two things will be adding here. These two things are there. This will be adding means sin square v plus cos square v equal to 1. You will cut. So finally we can write that y dou z by dou u, y dou z by dou u plus x dou z by dou v equal to e power 2u dou z by dou y sin square v plus cos square v, that is e power 2u dou z by dou y. This is the proof for this. Next we can do problem in Taylor series. Problem in Taylor series. Here I can write example number 1. Expand tan inverse of y by x about one comma one up to the second degree terms. Up to second degree terms. Can write the solution for this. First we have to write that the Taylor series at the point one comma one is f of x comma y equal to f of 1 comma 1 plus 1 by 1 factorial x minus 1 fx of 1 comma 1 plus y minus 1 fy of 1 comma 1 plus 1 by 2 factorial x minus 1 whole square fxx of 1 comma 1 plus 2 into x minus 1 y minus 1 fxy of 1 comma 1 plus y minus 1 whole square fy of 1 comma 1 plus x. Okay. Now for the given function we can find the value given f of x comma y tan inverse of y by x what is f of 1 comma 1 substituting x equal to 1 y equal to 1 then we get that tan inverse of 1 by 1 that means tan inverse of 1 tan inverse of 1 is pi by 4 because tan 45 degree is 1 so tan inverse of 1 is pi by 4. Next we have to differentiate one time f of x comma y partially with respect to x. So f of x comma y with respect to x partial because this step is over now. This step is over. Next we are coming to this step. Next we are going to find that fx and fy. So it is the 0th order. Actually this is the 0th order. Next we are moving to finding that first order. Okay. So differentiate f of x comma y with respect to x partially. We will get that fx of x comma y equal to what is tan inverse of y by x? Differentiation is 1 by 1 plus y by x whole square. Once again you have to differentiate y by x with respect to x means you have to keep it that y as constant. Y is constant here, therefore keep it y. Differentiation of 1 by x is minus 1 by x square, therefore you will get that minus y divided by x square plus y square. Since here you will get that minus y by x square, okay, 1 by here x square plus y square, one more divided by x square is there, so take it to the numerator, you will get that x square here, that x square get cancel, x square get cancel, then minus y by x square plus y square. Now you have to find that what is fx of 1 comma 1. That means you have to substitute x equal to 1, y equal to 1, minus 1 divided by 1 square plus 1 square is 1 minus 1 by 2. Next we have to find fy of x comma y. When you are differentiate f with respect to y means keep it x as constant. So that is equal to 1 by 1 plus y by x whole square, and then differentiation of y by x you are keeping x as a constant, na? differentiation of y is 1, keeping yx 1 by x is constant. Then next we are going to find that fy of 1 comma 1. So you have to differentiate very carefully. Now what is the value here? You are taking to that x in the numerator, then you will get that x divided by x square plus y square, x divided by x square plus y square. Therefore fy of 1 comma 1 is 1 divided by 1 plus 1, that is equal to 1 by 2. So therefore next we are moving to, so what are the things are completed now, you can see. So first 0th order is over, first order is over, next you have to go for that second order. So what are the second order terms here? fxx, fxy, fyy. So next we are going to find that second order values. When you are finding that second order values, you can find that fxx, fxx. See, fxx of x comma y means you are differentiating fx with respect to x again. That means dou f by dou x with respect to x again. Otherwise we can write this as dou by dou x of dou f by dou x. That means you are differentiate dou f by dou x with respect to x again. Here also you have to keep it that y as a constant. Y is constant here. That means, so dou by dou x of dou f by dou x means we can see dou by dou x of, what is dou f by dou x? Dou f by dou x is minus y divided by x square plus y square. But what is the formula for u by v? The differentiation of u by v formula you have to apply here, v square v du minus u dv formula you have to be applied. Therefore we can write this as x square plus y square whole square in the denominator, because it is in the u by v model. Here u, numerator is u, denominator is v. First you have to square that denominator, v square, x square plus y square. Differentiation of y is 0 because y is constant, minus, keep it y here, differentiation of x square plus y square. When you are differentiate x square you will get to 2x, and then differentiation of y square is 0. So what do you get here? 2xy, that is equal to 2xy divided by x square plus y square whole square. Now you have to substitute 1 comma 1 for that x value and y value. That means fxx of 1 comma 1 is, so 2 into 1 divided by 1 plus 1 whole square. Once again you will get 1 by 2 only. Next we need to find that fxy. That means either you can differentiate fx with respect to y or fy with respect to x, is it not? So now we have to differentiate dou by dou x. For example, we can take dou by dou x of fy. What is fy? Dou by dou x of minus y divided by x square plus y square. I think it is dou by dou y of, not dou by dou x, dou by dou y of minus y divided by x square plus y square. This one. Fx you are with differentiate with respect to y. So you will get that once again the same model, u by v model, that is denominator square, squaring the denominator x square plus y square whole square, and then keep it that x square plus y square, differentiation of minus y is minus 1 minus, keep it that minus y here, differentiation of x square plus y square is 2y. So what you get, that is equal to y square minus x square divided by x square plus y square whole square. Therefore, in case if you are finding that fxy of 1 comma 1, that is equal to 0. Okay, next we have to find that fyy. That means differentiate dou by dou y with respect to y. That means x divided by x square plus y square. In case if you are differentiating this, you will get the denominator is x square plus y square whole square. Then keep it that x square plus y square. You are differentiating with respect to y. Differentiation of x is 0 because x is a constant here. Okay, minus, keep it x, differentiation of x square plus y square is 2y. Differentiation of x is 0 because differentiation of constant is 0. Differentiation of y square is 2y. Therefore you will get that minus 2xy divided by x square plus y square whole square. So therefore what is fyy of 1 comma 1 is, you are substituting that, you will get that minus 1 by 2. So after finding all the values of first order, zeroth order and second order, you have to substitute all the values in the Taylor series formula. You know the Taylor series formula, f of x comma y equal to f of 1 comma 1. F of 1 comma 1 value is pi by 4 plus, for your quick reference, actually here you can draw some rectangle box for that important result. So here one important result is there, that is f of 1 comma 1. F of 1 comma 1 is pi by 4. So this is one important result. That is one. And then here fx of 1 comma 1, I can take it in red pen. It is one more. It is fy of 1 comma 1. And then you can do in pencil also to avoid the confusion. fxx, it is one result. fxy, one more result. The final result is fyy. So you have to be very carefully write that the values 5 by 4 plus x minus 1 minus 1 by 2 plus y minus 1 1 by 2 plus 1 by 2 factorial is 1 by 2, then x minus 1 whole square into 1 by 2 plus x minus 1 into y minus 1, then fxy value is 0 plus y minus 1 whole square, fxy value is minus 1 by 2 plus etc. So what is the final answer here? Tan inverse of y by x. What is f of x comma y? Given value is tan inverse of y by x equal to pi by 4 minus 1 by 2, take it outside, minus 1 by 2 x minus 1, either you can take it outside or you can write directly, plus 1 by 2 y minus 1 plus 1 by 4 x minus 1 whole square minus 1 by 4 y minus 1 whole square is the answer. Okay, thank you. In the next class we'll discuss few more problems.